Today we are going to look at another rule that will help us find the slope of the tangent line at any point, what we call the derivative. And today we're going to look at a product rule, which deals with questions where there are multiple factors and we don't want to multiply them out. So to illustrate the product rule, which is stated right here and above as well, that we're going to use this quadratic expression, and if I was to use the elementary rule, I would multiply it out. 6x squared minus 15 plus 2 is minus 17x minus 5, and then when I find the derivative, I would get 6 times 2 is 12, subtract 1 from the exponent, and then minus 17. That's the answer, and it would make sense to do it that way. The product rule will allow us to do the same thing slightly different. Here's what the product rule says. The product rule says the derivative is the derivative of the first factor, which would be 2, times the second factor, which remains the same, plus, always a plus in between, the derivative of the second factor, which is over here, which would be 3, times the first factor as itself. And when we simplify that, I get 6x plus 2 plus 6x minus 15, and voila, where did I make a mistake? Somewhere, because I get 12x. Did I do multiplying over here? Minus 15 plus 2. This should have been a minus 13. Anyways, sorry about that. Either way, you get the same answer. And really for that, it doesn't come into play, but what if you get into more complicated expressions, such as the ones you see here? How are we going to deal with them with the product rule? Does it actually save us time? Well, let's go ahead and do this one. The derivative of y with respect to x. What is the slope of the tangent line at any point? So I take the derivative of the first factor, which would be 6x. Leave the second the same. Plus the derivative of the second factor, which would be 4 times 2 is 8x cubed minus 12x squared, times the first, which remains the same. And then we can simplify that and multiply everything out and add things together that go together. And in this case, the only ones that would go together are those, and then these would be added together, and you would get your answer as being 36x to the 5th minus 60x to the 4. And if you can take a common factor out of there, you should. 6 will definitely go into each, and there's x to the 4, so you get 6x minus 10. Oh, there's more. Should have taken out more. 6 to 2 is 12. It actually goes into those. There you go. And the next one would be the same. Now, it will get more complicated. As you can see here, we have a relatively complicated expression with negative exponents and root exponents, and we have questions here where you're going to need to change it as you write down the question to a root expression in order for you to find success, and you're going to have to be very careful. On these ones, you're not going to simplify like we did here because your expressions are going to be quite complicated. So here's the assignment on page 191, and you're going to need some help as you go, and make sure you ask, and I will be glad to help you out.